Hi, Lucas.
Hello?
Yeah, how are you doing today?
Good.
Do you have a final coming up in a couple days or so?
I have my final tomorrow, actually.
Tomorrow. Everybody's, I guess, is Tuesday and Wednesday because I'm booked solid today and tomorrow, and I got almost nothing on Wednesday.
Yeah.
Okay. What do you got
All right.
review?
I have a review packet.
Okay.
And the first question, find all the zeros for the function, give exact values wherever possible, identify each zero as rational or irrational. And the function is x cubed minus 5x squared minus 3x plus 15.
All right. Whenever you're talking about finding the zeros of things bigger than quadratics, it's extremely difficult. If you're talking about cubics, which is what this is, if it's groupable, that's the only easy method of doing it. If it's not groupable, it's extremely difficult. It's a 20-minute problem full of trial and error and all of that. This is groupable. Why is it groupable?
Because there's 3 and 5 in 15, so they're kind of like...
The ratio of this coefficient to this coefficient is the same as the ratio of that coefficient to that coefficient. Because this is a 1 right here.
Yeah.
That's what makes it groupable. Okay? If it's groupable, it's pretty easy to do. So all you do is group the first two terms together and the second two terms together. So, if I want to group the first two terms together, I put a parentheses around it. What goes in this set of parentheses?
3x plus 15.
If I write that, is that the same as the top?
No.
Okay, what do I have to do to the bottom to make it the same as the top?
Oh, you have to make it a 3x minus 15.
There you go. At every step of the way on these problems, you should check to make sure you have not changed it. Because this is an extremely easy mistake to make. Okay, so now we have the same thing as the top. Now, factor out the greatest common factor from the left parentheses.
X squared.
Leaving
X minus 5.
And on the right,
3. Leaving X minus 5.
Now, factor out something from that expression.
The X minus 5. So it's X squared or X minus 5 times X squared minus 3.
There's your answer. Well, not quite. In other words, they said find all the zeros. So if I set that equal to 0, that allows me to find all the zeros. What are all the zeros?
1 is 5. And plus or
Yeah.
Plus or minus the square root of 3?
Yes. In other words, we get the other one by setting this thing equal to 0. Well, if I set x squared minus 3 equal to 0, that means x squared equals 3, which means x equals plus or minus the square root of 3.
Okay.
Okay? And the thing most people forget is this plus minus. What should help you to remember it on this particular problem is the fact that we start out with a cubic. When we see that we're starting with a cubic, we need to expect 3 solutions. Not 2, not 1, but 3.
Yeah.
So if you were to make the typical mistake, which would be to leave the plus or minus off, that's only 2 solutions there.
Yeah, that's actually why I said plus or minus, because...
Well, good. Good. That's a good thing to remember, is the fact you're looking for 3 solutions, and therefore we need 2 of them on this one.
Mm-hmm.
All right. What else?
Next one. Identify the maximum and minimum of the functions, and it's y equals 7 cosine x.
What's the maximum value that cosine x can have?
1.
So what's the maximum value that y can have?
1.
7 times 1.
Yeah.
So 7. You see?
Yeah.
Okay. What's the minimum value that y can have?
The minimum it can have is negative 7?
Yeah. In other words, cosine x bounces back and forth between 1 and minus 1. It can never be greater than 1. It can never be less than minus 1.
Yeah.
So the minimum, the maximum that function can ever be is when cosine x is equal to its maximum, which is 1. And the minimum the function can ever be is when cosine x equals its minimum, which is minus 1.
Yeah.
Okay.
All right. Next one is solve the inequality, and it's x is less than or equal to 4t plus 1, which is less than 9.
Like that?
Yeah. Oh, and it's x is less than or equal to 4t.
And we're supposed to solve this for t?
Yeah.
Okay. So what we need to do is get t alone in the middle, like that.
All right, so first I would subtract 1 from all 3 of them. So it's x minus 1, 9, or 8.
Now we got that.
And then divide by 4.
So we end up with t is greater than or equal to x minus 1 over 4 and less than 2.
Yeah. And now we can... Well, wait, there's 2 variables.
I know. It's not usual that you get 2 variables. I was a little surprised when you gave me 2 variables.
Oh, sorry, I missaid it. It's 0 is less than or equal to 4t.
Oh.
So it would actually be negative 1/4.
Yeah.
And then now it makes sense.
Okay, so this is negative 1.
1/4. Negative 1/4.
The bottom answer is, yeah, negative 1/4.
Yeah, so then, yeah, all right. Then last is, or now, solve the equation by factoring, and it's x squared minus x minus 72. So it's x minus 9x plus 8.
So what's the solution?
The solution is 9 and 8, so x equals 9 and x equals 8.
Okay. The way.
Or negative 8. Negative 8.
Good. Thank you. I was about to launch into a whole nother explanation.
Yeah. All right. Compute the exact value of the function for the given x value without using a calculator. F of x equals 3x for x equals negative 2. So it's negative 6.
Yeah. In other words, f of negative 2 would be negative 6.
Yeah. All right. And then find the exact solution to the equation log base 5x equals 3.
Okay, put that into exponential format.
5 to the third equals x.
The way I remember this is it's always the entity on the far left raised to the power on the far right equals the thing in the middle.
Yeah. And then, so that would be 125?
Yep.
All right. Now, I think all right, solve the equation. I think we've done all of them now, because we worked on this on, Jesus, that was quick. Well, actually, no, we have a couple more.
Okay.
1/2 6 quantity 6x minus 10 equals 1/4 quantity 20x minus 12.
You have two ways you can do this. Because everything is such nice round whole numbers, I could choose to distribute the 1/2 and the 1/4 and go from there.
Yeah.
That's not the way I would normally do it, because normally you're not going to have such nice round whole numbers. In other words, if I turn that thing into a 9, now distributing doesn't work so well.
Yeah.
As long as this is a whole number such that when I multiply it by 1/2 it remains a whole number, then that's a fine first way to go. So I could do 3x minus 5 equals 5x minus 3. That simplifies it immediately.
So would it be 1?
Well, you get 2x.
No, negative 1.
Right. 2x equals minus 2, so x equals minus 1.
Yeah.
Let's look at this problem just for a second more. If it's a little different, like that, now my first step is not going to be to distribute the fractions. What would the better first step be?
The better first step would be to,
in fact,
maybe factor out this.
Well, no, let's make it even more difficult. In other words, if this was the problem, now if I distribute both fractions, I end up with fractions on both sides with different denominators.
Yeah.
So you don't want that. So there's a much easier first step. What would the first step? How can I get rid of all the denominators in one step?
I would multiply both sides by 4.
Good. That gives me 12x minus 18 equals 20x minus 11. And now it becomes a very simple problem.
Yeah.
Okay. So normally my first step is to get rid of denominators, always. But with this particular problem, you don't really need to get rid of the denominators. You can distribute it and still end up with whole numbers. You don't end up with fractions anywhere.
Yeah.
So it kind of depends on the problem as to which is the best first step. My typical first step in an equation is to try to rid myself of all denominators, because usually it's never this simple. Usually when you have a few denominators, they do make it a 9 there and an 11 there. You know what I'm saying?
Yeah.
It's rare that they put fractions in and you can distribute and still get whole numbers.
Yeah. All right. So the next problem is x plus 7 over 8 equals x plus 8 over 9.
Two possible ways to do this. Our goal is to get rid of the denominators as quickly as possible.
Yeah. I don't know. So we would have to find the least common multiple of
8 and 9, which is 72. That's one way to do it. Turns out that that's probably not the easiest way. Think.
Yeah, because you get huge numbers.
Well, it's not that. It's just that this, I can get rid of both denominators rather quickly by cross-multiplying. Let's multiply that by that and multiply that by that in one step. What do we have?
We have 9x plus 63 and 8x plus 64. Yeah.
Now, notice that that's exactly the same thing we would have gotten if we'd have multiplied both sides by 72, which is the least common multiple that you, or the least common denominator, whatever you want to call it.
Yeah.
Same thing. It's just that cross-multiplying didn't require us to even figure out what the least common multiple was. So all we had to do was cross-multiply. It took care of itself. I didn't need to think and come up with 72 was the least common multiple.
Yeah. All right, next is find all asymptotes for x minus 9, or quantity x minus 9 times x plus 6 over x squared minus 9. So
always, pretty much you can almost say that no matter what the problem, if you can factor something, factor.
yeah,
That's the bottom
so
factor.
That's x plus 3x minus 3.
Can I cancel anything?
No.
What are my vertical asymptotes?
Vertical asymptotes are -6 and 9.
Vertical asymptotes you get whenever the denominator is 0.
Oh, yeah, yeah. So it's -3, or -3 and +3.
What are the horizontal asymptotes?
Is it 0? No, it's 1.
Very good. It's the ratio of the coefficients of the leading term. Well, this leading term is x squared. This leading term is x squared. That coefficient is 1. That coefficient of 1. The ratio is 1. So we have a horizontal asymptote right there.
Yeah. But, yeah, never mind.
What else did they want
Yeah,
besides the vertical and horizontal asymptote?
I think that's
Now
it.
notice these asymptotes are equations of lines. So it's not correct to say there's a vertical asymptote at 3. There's a vertical asymptote at x equal -3 or x equal 3. There's a horizontal asymptote at y equal 1.
Yeah.
Okay.
All right. Couple more questions.
Okay.
Find the period of y equals 5 sine quantity 1/2 x minus pi over 6.
Period equals what? What's the formula for a period?
Oh, it's like a sine something. I don't know. I can't remember.
Here's the general form of the sinusoidal equation.
Yeah.
The period is related to b. And it's related in the following manner. The period is equal to 2 pi over b. Or if you know b, the b is equal to the 2 pi over the period. Notice that both of those have to be correct if one of them is correct.
Yeah.
Okay, so they're asking about the period. It's 2 pi over b. What is b?
B is 1/2.
So what's the period?
Period is 1 pi. No, 4 pi.
There you go. Be careful with that. It's a common mistake you can make. In other words, when you're dividing by a fraction, make sure you flip the fraction and multiply.
Yeah.
And these kind of questions, you're going to get just as many where they give you b and they ask you for the period, like this. Or another way would be to give you a graph and say, what is b?
Yeah.
What is b from the graph I just drew?
B is 2.
Yeah. It's 2 pi over the period, and the period here is pi.
Yeah.
So it would be 2.
All right. And then can we do some more questions like that, because I'm not like too solid with the sinusoid functions.
Sure. Let me go back to where I've got it written. First of all, is that the standard for you? Because different school systems have different standards. This is not my favorite standard. My favorite standard is this one, where the b is outside the parentheses.
No, I think we have the b inside the parentheses.
Okay, there's nothing wrong with that. It depends on the equation you're given. In other words, the equation you just gave me, the 1/2 was inside the parentheses. So it doesn't matter as far as b goes, whether it's inside or outside. What does matter is what the phase shift is. The reason I like this format better is because I can say the phase shift is c. Whereas with your format, the phase shift is c divided by b.
Yeah.
In other words, I have to factor out this b in order to get it into this format.
Yeah.
And when you do that, you divide this by b also. So it's really a significant difference in format. It's kind of a shame that different math curriculums have decided on these different formats because it's nothing but confusing to students. But as long as you know that it doesn't matter, in other words, if I would have said this, if I give you this equation, what's the phase shift on my y sub 1?
Phase shift is pi over 6.
Yeah, it's just c. It's real simple when the b is outside the parentheses.
Yeah.
What's the phase shift on the one you gave me?
It's 2 pi over 6.
Right. So the phase shift's a little harder to figure out when the b is inside the parentheses.
Yeah.
So as long as you're aware, in other words, whenever you see a sinusoidal function, be aware of what they're giving you. Is that b inside or outside? In other words, it really doesn't matter what you're taught. It doesn't matter whether you're taught this one or this one. What matters is what you get as a function.
Yeah.
Okay.
All right. Next one is y equals sine square root of 2 over 4.
And what are we supposed to do?
You're supposed to find the exact value of real number of y.
Okay. With your calculator?
Yeah.
Okay.
So I just want to know like how you do that.
Do it like this.
All right. So, okay, so you would put in root 2 over 4.
In parentheses. In other words,
And
don't use the parentheses. It's going to find the sine of the square root of 2 and then divide that answer by 4.
Yeah. And so, and I would have to have my calculator in radian mode for that.
Not necessarily. They don't really tell you whether this is in degrees or radians. Usually if it's in radians, there's a pi in there. So the fact that there's no pi, you don't really know whether they're talking degrees or radians. You have to know.
Yeah.
You have to know, because it could be either one.
All right. Great. I think that's going to be really helpful then. And we did my entire review packet. So I think I'm going to go over it some more probably tomorrow morning and then do my test. But if you want, we can end it here.
That's fine. I'm perfectly fine with ending it here. I got 6 hours of tutoring today, so I don't mind. But I want to make sure we cover everything you need to cover.
Well,
you said you were a little confused on sinusoid function. Do you want me to give you a few?
Yeah, that would actually be really helpful too.
Okay. Let me just give you one and make sure that you are really good with it. And this time I'm going to put this thing outside the parentheses because regardless of what format they've taught you, they may trip you up by putting that b outside of the parentheses.
Yeah.
So how would I graph this function?
Well,
This has got pretty much everything that can be done to the sinusoid function.
So the original sine function would start at 0, 0 and go up to 1 and down. So this one would be switched. So
the best way to do these, I think, is to list A, B, C, and D for starter.
Well, A is -2, B is 2, C is pi over 2, and D is 3.
Now, make sure you find the period and the phase shift.
The period is pi over 2, or 90 degrees.
Hold on. Remember, the period is 2 pi over b.
Oh, yeah. So it's pi, right?
Yeah.
So it's 180 degrees.
Right. What's the phase shift?
The phase shift is pi over 2.
Okay. And the vertical shift is 3.
3. And then the maximum and minimum are -2 and 2.
Yeah. Let's apply each of these one at a time.
All right.
The first one.
That's what I was.
The first one that should be applied is probably D.
So it's up 3.
Yeah. Let's make a new line of symmetry right there.
All right.
Second one that should be applied is the phase shift. Where do I start my curve?
The curve starts at pi over 2.
Right. Where do I end my curve?
Your curve ends at 2 pi?
No?
Or no. 2. Is it? It's like with one more pi over 2.
It's a period plus pi over 2, right? What's the period?
Yeah. The period is pi.
Okay, so I got to go from pi over 2 to 3 pi over 2.
Yeah.
I got to draw one full cycle in that time period.
Yeah.
Now, so I'm going to start here, and I'm going to draw the sine curve. How high should I go?
You should go to 5.
Okay, good.
And 1.
Okay, good. So I gotta go up to there at that point. Well, let's see. Hold on a second. In other words,
you need to divide pi over 2 and 3 pi over 2 into quarters.
Right, exactly. Exactly. Okay. Now, approximately that's going to be my result.
Yeah.
What did I miss? That is actually the curve of 2 sine of 2, everything except the negative sign. What does the negative sign do?
So you need to go down to 1 at the beginning and then up to 5 and then come back down for...
Yeah, I need to take my curve and reflect it over the x-axis.
Yeah, so...
Do I do that reflection first or last?
Last?
First. I did it wrong. I should have reflected first. In other words, my initial curve, let me erase what I have here. My initial curve looks like this.
Yeah,
that is y equals minus sine of x.
Yeah.
Now I do everything to it. In other words, you always do reflections first, not last, and it does make a difference in a lot of cases. In other words, now I can do everything else at the same time. In other words, I can start it at pi over 2. I can shift it up 3 units. So it now gets shifted to 3. There's still my line of symmetry, only now I'm going to start here and
it wouldn't go down below 0 though, would
right. In other words, I'm drawing these one at a time.
Oh, okay.
I find the best way to do these things is kind of one piece at a time. Okay? So let's erase that and start with the phase shift. So I know that I'm going to start here. I'm going to go down 2 units, so I'm going to go down to -1.
Yeah.
And I have to end at 3 pi over 2. So something like that, where it goes up to 5, down to 1, and in fact, that's it.
Yeah.
That is a negative reflection with a period of pi, with a phase shift of pi over 2, and a vertical shift of 3.
Yeah.
And that, I think, is the best way to do this type of problem. And of course, the other way you have to go is where they give you a curve and you have to come up with the formula.
Yeah.
As long as you can do both of those processes, you're in good shape.
All right.
All right. Anything else, or will that take care of you today, Lucas?
I think that'll take care of it.
Sounds good. You
All
have
right.
a good luck on your test, and have a good holidays, and I'll probably talk to you at the end of the holidays.
Yeah. You too.
All right. Bye-bye.
Bye.